A visual recommendation system serves two major purposes. It gives the user the results they want in a visual format which can be more comprehensible, and it provides the users more control in terms of the kind of results they want. It is user driven, and it makes it more effective and satisfying. In our project, we focus on the dataset from Stack Overflow, Java, and use it to design a visual recommendation system around it. This system lets the user navigate and explore the Stack Overflow dataset in a way which is both easy and effective. We hope to make it a user-friendly and user-centric portal for all things Java. The research questions and the problems that we are trying to tackle are: how does data visualization affect the experience of using a static recommendation system? How do novice users with no experience in Java navigate the system? The main driving force of our recommendation system is text analysis and data mining. As the data set that our system is based on is mainly text, the most important task to perform is to find relationships between the text in the dataset and generate relevant and sensible analysis from these relationships. Let us run an example and see how it works. Now, this is a landing page. The user gets to enter any query. Once we enter the query, the user is provided with different visualizations. Now let's see what happens behind the scenes. Once we have the input query, the backend does topic modeling on the string with the help of tools like POS tagging and TF-IDF. We extract the topic and then use Word2Vec to extend the list of important keywords. Word2Vec is trained on our dataset as well as the complete Java Oracle library. Once we have all the keywords, we map it to the existing list of discussions. After this step, we get a list of discussions which are then ranked based on similarity. To achieve accuracy, we use two types of similarity: title and question similarity. Now the user has control over the weight of these two similarities. As you can see, the size changes uh, according to the value of the question similarity. Once we compute the total weight of each discussion, the top discussions are displayed to the user. After our initial data analysis phase, we came to the conclusion that user reputation, acceptance rate, and number of votes are the three most important factors to extract the most relevant discussion from the dataset. Our first visualization is where we provide the user with a clear distinction among the three categories. Each bubble represents a discussion. The size of each bubble is based on its question similarity, and the color is based on the title similarity of the discussion. We choose to represent our main discussion in the form of bubbles because bubbles clearly show the data, and we also get other dimensions like size, color, and closeness to model other variables in one collective chart of bubbles. We also provide the user with textual information. The color of each text depends on the combined weight, which is equal to the sum of title and question similarity. Once the user clicks on the bubble, the corresponding discussion is then highlighted. Our second visualization is a network visualization, which shows a network based on the inter-keyword relationships. The keywords extracted from the user's search string are then processed to generate related keywords, which will give the user details about how different questions relate to one another. It is a forced layout network with the center node being the most well connected node. We use this visualization to provide the novice users a chance to easily navigate through the entire dataset even with little knowledge of Java. The front end of the system was created using HTML, JS, CSS, jQuery, Ajax, and D3 for visualizations. For backend, we used Node.js as a server. The front end connects to the backend using HTTP request and response objects. Data cleaning, mining, and analysis is done using Python and its frameworks. Our database is set up on MongoDB. We have processed the results on a given dataset and stored it accordingly in our database to save on computation time. We are connecting server-side Node.js through zero RPC calls, which are served by a zero MQ server, which is a message queuing framework. This lets us independently run Python module, which is used for text processing, and Node.js, which handles the request response cycle. This is the overview of a system, and further description is available in our project report. Thank you.